All right, so whenever a is 1 like this, just take half of that exponent, and that goes with the x's. Since it's x squared, it's just x times x. If it was x to the 6th, they'd be x cubed. If it was x to the 10th, they'd be x to the 5th. So I just cut them in half, okay? But the majority of the time, it'll just be x squared, okay? Now, I'm looking for factors of c, -3. You know, what multiplies to equal -3 but adds to equal +2? Well, there's only two factors of -3. -3 times 1 or 3 times -1, right? Which one of those two add up to +2? The bottom one, right? So over here, I'm going to put a +3 and a -1. I just factored that. So that's a real easy example because -3 doesn't have a lot of factors. So it's easy to pick that out quick. No.
I remember Mr. Laverick, it would be like that's an easy type, and then whenever there's a number in front of the x, it's a hard type.
Yeah.
Something like that. Is that this?
Yes. But it's not so hard. The one you got a number in front. And we'll go over some of those today too. All right, so this one. Is there a GCF? Is there something that goes into all three of them? No. Okay. It's got to be all three. And it can be letters or numbers, right? Or both. All right, it's got three terms. Are these both positive perfect squares? I've jumped down to number 4 on our list because it's got three terms. Is 56 a perfect square? No. So it's one of those regular trinomials. All right? Since C is positive, my parentheses will have the same sign that's in front of B. So these are both plus. If that was a minus 15x, these would both be minus. Okay? So what I'm looking at, again, is what multiplies to be 56, but adds to be 15. All right? So, you know, if I write all the multiples of 56, I got 1 and 56, 2 and 28, 3 doesn't work. And I know 3 doesn't work because what do I get when I add 5 and 6? 11. Is 11 a multiple of 3? No. So 3 won't go into the number. You can add the digits of a number. If it's a multiple of 3, after you add them up, then 3 goes into it. That works for 3 and 9. Just a little trick there. All right. 4 goes into 56. What is that? 14 times, I think. 5 won't go into 56. And again, if I add these, I get 57, 30, 18. What do I want? 15. So none of those work yet. 5 won't work because it's got to end in a 0 or a 5. You guys knew that, right? 6 doesn't work because 3 doesn't work. If it's even and 3 works, that means 6 works, right? Because 2 and 3 go into it. 7 works. 7 times 8 is 56, right? What is 7 plus 8? So that's the 2 I want, right? So I put 7 and 8, and I've got it factored. Now, you don't have to write them all out like I did. You can do that in your head if you want or on your calculator. But if that helps you, go ahead and write them out. Any questions on that example?
Would you still get points if the 8 and 7 were flipped?
Yes. Good question. It doesn't matter where the 8 and 7 are. Just make sure they're both positive. Okay? Is there a GCF?
No.
No. I know it's not a difference of squares or sum or difference of cubes because those only have 2 terms. I know it's not a special trinomial, number 4, because it's not a positive perfect square for C. 12 is not a perfect square, and again, it's not positive. So it's one of those regulars. And again, since A is 1, it's just going to be x times x. And since 12 is negative, one of these is plus and one's minus. All right? So I'm looking for factors. What multiplies to to get negative 12 and adds to get positive 4. So, you know, you could go 1 and negative 12, or negative 1 and positive 12, 2 and negative 6, or negative 2 and positive 6, and I think that's the one, isn't it? Won't that give you the 4? So the 2 would be with my minus sign, and the 6 would be with my plus sign. And again, if you put x minus 2 first and then x plus 6, that's okay. Just make sure the 6 has the plus with it and the 2 has the minus with it. Just coming back to you guys, these are the easy ones.
Yeah.
Right? Who wants to, this is just like the other two. A plus and a minus because it's negative 30. What numbers, Addie?
No, I was
Oh,
gonna ask,
okay.
isn't it supposed to be 2 negatives because the B is a negative?
No, when C is positive, then they would have both been negative. Okay? So when it's positive, like this 56, they're both whatever's in front of the 15. But when C is negative, we're always going to have 1 plus and 1 minus. So since this 30 is negative, got a 1 plus and minus. Noah.
Negative 6 plus 5.
Right. So the 5 is the positive, the 6 is the negative. Because when I add negative 6 plus 5, I get that negative 1. Questions? Okay. Now, that's when A is 1. When A is not 1, like this one, all right, here's what I do. Now, you might have been taught in Algebra 1 to do a little guessing and checking. You pick factors of 6x squared, which would be 1x and 6x, or 2x and 3x. You pick factors of 10, 1 and 10, or 2 and 5. And then you try to find the right combination that works to give you 19x in the middle. If you're good at that method, you can do that method. That's fine. That's not how I teach it, though. Here's what I do. First of all, I check and make sure there's no GCF. There's no number that goes into all three of them, is there? And there's not an X in the last one, so there's no letter in all three of them either. So what I do then is I take the A value and I multiply it by the C value, and I get 60. And I do the same thing I've been doing. Multiplies for 60, adds for 19. So what times what is 60, but adds is 19. That's what you're thinking about. Okay. Right, 4 times 15. Those are what? Oops, not 5, I'm sorry. 4 times 15 is 60, and 4 plus 15 is 19. So since C is plus, all right, everything's going to be plus. So here's what you do. You're going to rewrite this problem. The first term, the 6x squared, doesn't change. The 10, the C, doesn't change. What changes, the 19 you rewrite is plus 4x and plus 15x. So those two numbers that got you 60, you replace the 19 with. So what you have done is have turned it into a grouping problem. Okay, what we're going to do is we're going to group first two together and the last two. And then I'm going to look for the GCF. What's the greatest common factor between 6x squared and 4x? 2x. What's the greatest common factor between 15x and 10? 5. When you take out GCFs, you divide the GCF into the terms. Since there's two terms here, 6x squared and the 4x, there should be two terms here. I've got two terms, 15x and 10, So there should be 2 terms in here, okay? Make sure, sometimes if these are the same numbers, some people say, well, they just cancel out and they don't put a number there. If they are the same number, the answer is 1, right? So you have to put the 1 out, okay? So what is 6x squared divided by 2x? 3x. What's 4x divided by 2x? 2. What's 15x divided by 5? What's 10 divided by 2? I'm sorry, 10 divided by 5. What do you notice about the green?
They're all the same.
They're the same. That's what's supposed to happen. If it's factorable, they're the same, like this is. Okay? When you see this, one of your factors is that 3x plus 2. What's your other factor? 2x plus 5. The GCFs you pulled out becomes the other factor. If I wanted to check to see if I was right, I would FOIL those. And I guarantee that if I FOIL these, when I'm done, I'll get 6x squared plus 19x plus 10. No guessing and checking there. But, like I said, if you're good at guessing and checking, and getting the right stuff in your head there, that's fine. You can do it the other way, if that's what you learned in the past. I like this way because it eliminates the guessing. Questions? I have any more? I think that's it for this slide. All right, let's look at here. So is there a GCF? No. So these aren't both positive perfect squares. So it's a regular trinomial like we've been doing. So I'm going to multiply 3 times 2 and get 6. What factors of 6 add to give me 7? 6 and 1. Okay? So we're going to rewrite it as 3x squared plus 6x plus 1x plus 2. Remember, the first and the last term, the 3x squared and the 2 don't change. It's the middle one, the b, you split up into the 2. All right? Take your x with them. Whatever's with the b, all right, goes with the 2 numbers you got. Since that's x, these are 6x and 1x. If this was 7xy, then this would be 6xy and 1xy. Okay? Now, we group. All right, what's the GCF or common to the first group? 3x. What's common to the second group? Right. Nothing's common, really, right? But you have to pull a number out. So if nothing's common, you pull the number 1 out. Because 1's common to everything. All right? And then we divide. 3x squared divided by 3x. 1x. 6x divided by 3x is 2. 1x divided by 1. 2 divided by 1. Working out? Yeah. Kenzie, what's my answer?
X plus 2 3x plus 1.
Good. That is correct. So these are the ones that you said, Mr. Laverick said were the hard ones.
Yeah.
Okay. At first they are a little harder, but once you do a few, they become not so bad. Simple, right? You guys try that one on your own quick. I'll give you 2 minutes because it's simple. Okay. Nothing GCF, so what do I gotta do with the 3 and the 5? Multiply them, right? Whoa, jumped on me there. 3 times 5 is what? 15. Adds to get what? Negative 16. What do we say? When the third's plus, they're both whatever that is, right? And in this case, they're both negative, right? So -1 and -15. You see that? So I go 3x squared minus 1x minus 15x. Now, if you put minus 15x minus 1x, it's okay. It'll still work out. Doesn't matter what order you put them in. But this is important. When I group and the third term has a minus in front of it, put it inside the group. All right, what's common to the first group? 1x, right? Or just x. Oops, I want to put purple there. Whenever this third term has a minus or a negative sign in front of it, like this 15 does, pull the negative sign out. What goes into 15x and 5? 5. All right. What's 3x squared divided by 1x? What's negative 1x divided by 1x? Negative 1. What's negative 15x divided by negative 5? Positive 3x, right? What's positive 5 divided by negative 5? Negative 1. So you got to pull that negative out so that these will be the same. That 3x minus 1 shows up. No,
I flipped them, is that okay?
yes. You'll still get the right answer. It just looks a little different to work. So our answer then is 3x minus 1, one factor, and the other factors 1x, or just x minus 5. Those making sense? All right. Good. Good job on those. All right, we've already been talking about GCF. All right? But it's the greatest common factor. It says if this is the case, that number variable can be pulled out before factoring by grouping. All right? Or whatever else. It could be anything. It could be a difference of squares after we pull out the GCF. All right? So it doesn't have to be grouping. Also, if the leading coefficient of the trinomial, the leading coefficient's that first one. That one's a 3. This one's 3 also. We didn't do this one, but that's a 6. We call those the leading coefficient. All right, that's the one in front of the x squared, the a value. All right, so if it's negative, you can pull out a -1, -1, or if a 3 goes into all 3, you can pull out a -3, and to make your leading coefficient positive. It's always easier to factor when that leading coefficient's positive. Okay? So if there's a negative out front, pull that negative out. Or actually, it's a -1, but we usually just put the negative sign. All right, so is there a GCF here? Is there a number that goes into all 3? Is there any letters that go into all 3? Yeah, so bring them both out. What are they? 3x. Then we divide all 3 of those by 3x. 3x cubed divided by 3x is x squared. 12x squared divided by 3x is 4x. Negative 36x divided by 3x is -12. We're not finished because what's in parentheses there can be factored as well. All right, so we pull the GCF out. That's still part of my answer. And this is one of these regular trinomials where a is 1, so just x times x. It's -12, so I need a plus and a minus. So what factors of -12 add up to +4? Noah?
6 and -2.
Correct. So now it's factored completely. Does that make sense? Any questions? So it's like an extra step. We pull out the GCF first, and then we do what we've been doing. What's the GCF?
4y.
4y, but since that first one's negative, to make it easier, pull out the negative, all right? So pull out negative 4y. Negative 4x squared y divided by negative 4y is a positive x squared. 4xy positive divided by negative 4y is negative x. Positive 120y divided by negative 4y is negative 30. I think we already did one like this with the negative 30, didn't we? A is 1, so it's just x times x. Negative 30, so one's plus, one's minus. What factors of negative 30 add up to negative 1? Eli.
Positive 5, negative 6.
Correct. 5 times negative 6 is negative 30, but 5 plus negative 6 gives you the negative 1. Questions? Making sense? All right. So we're good with GCFs? Good with regular trinomials? Good with when we got A? Not 1. So far, so good? All right, one more type we're going to go over today. Difference of squares. Number 2 on our list. 2 terms. They're both perfect squares. Any variable to an even power. 4 is a square, so is 9. And it's got to be minus between them. Okay? Once you recognize it's one of those, to get these 2x, you got to take the square root. All right? And here's what you do. The square root of 4x squared is 2x, and that goes in the front of both sets of parentheses. The square root of 9 is 3. That goes in the back of both sets. And then one's addition and one's subtraction. All right, one of each, a plus and a minus, or a minus and plus. But that doesn't matter. But again, the way I got 2x was taking the square root of the 4x squared. The way I got 3 was taking the square root of the 9. Okay? Is there a GCF? First thing I always look for. Yeah, Patty, what is it? No, bigger. I want the greatest. 2 is a common factor, but it's not the greatest common factor. Yeah, 4. All right? So we're going to take the 4 out. What's 100 divided by 4? So this is 25x squared. What's 4 divided by 4? 1, so just y squared. Are these perfect squares? Any variable to an even power is a perfect square. Okay? 25 is a square, right? So, I put my 4 down, don't forget about it. Make 2 sets of parentheses, and now you square root. What's the square root of 25x squared? 5x. What's the square root of y squared? Y. Then what?
1 plus, 1 minus.
1 plus, 1 minus. What if that was a y to the 6th? What's the square root of y to the 6th? No, just y to the 3rd. Just cut it in half. The square root of an even exponent is just cutting that number in half. Okay? Is there a GCF? 1, yeah, but do we worry about the 1? No. So, it's a difference of squares because we got even exponents. 1 and 25 are perfect squares again. What's the square root of x to the fourth? X to the second. Cut it in half. What's the square root of 25y to the sixth? 5y cubed, yeah, to the third. Cut the 6 in half. Then what? 1 plus, 1 minus. GCF? No. Perfect squares? Yes. Minus between them? Yes. So, make your two sets of parentheses. What's the square root of 121x squared? 11x. Very good. What's the square root of 4y to the 8th? 2y to the 4th. Very good. Then what? 1 plus, 1 minus. We're getting the hang of these? What do we call these? Difference of squares. GCF. 2. What's 2x to the 4th divided by 2? What's 32 divided by 2? Are we done? No. What's this thing called? A difference of squares. Okay? What's the square root of x to the 4th? What's the square root of 16? Then what? We done? No. Is that a difference of squares? Difference of squares. No. Is this a difference of squares? Yes. It's like a factor tree, right? What's the square root of x squared? Square root of 4. Plus minus. Are we done now?
Yes, done.
Yeah, there's no more difference of squares left, is there?
I was like, yeah, that's like.
Here's your assignment.
Oh, you're joking.
Good job. Monday, I have a little factoring worksheet you can work on in class, all right? Good job.
I'm gonna forget all about this. That's true. I know, but I kept thinking.